All right, so what we're looking at here is the LowFlow valve sizing program. We call it JVCV. And what this does is this is a program that allows you to correctly size a valve based on the given inlet pressure, outlet pressure, temperature, and flow rate for a given application. We use this program for sizing both regulators, depending on the model, as well as sizing all of our control valves. So I'm just going to walk through two different scenarios here, one for sizing for regulators and one sizing for control valves. So if I look on the right side of the screen here, I am presented with three different modules. One says Jordan valve, one says LowFlow, the other says SteriFlow. So you just select which module that you are sizing for, so which product line you're looking at. So I'm going to switch this to a globe style LowFlow regulator. And then in the top left here, I have a couple different options that I can select from as far as the type of valve. So right now it's at globe, and I'm going to keep it at globe. But based on the drop down, you can see that you can also choose 708 or 8000G, which are the LowFlow control valve models. We have right underneath that we have the fluid state, so you can select liquid, gas, or steam depending on what you're sizing. And then based on that selection, the fluid name below it, that drop-down box will change. So I have it selected to liquid right now, and it defaults to water. But if I click this drop-down box, you can see, 20 or 30 different liquids that you can choose from. If I change it to gas, it defaults to air, and the same thing. You can click the drop-down box, and there's a ton of different gas, ton of different gases you can select from. So I'm going to change this back to liquid and change this back to water, since we're going to size a water application. And so the information you need when you size for a regulator for control valves, you need your inlet pressure, your outlet pressure, your temperature, and your flow rate. So I'm just going to go in and plug in a couple different inlet and outlet pressures. Keep this 100, 150, and 200 PSI. Keep a consistent outlet pressure of 50 PSI. Keep 70 degrees, just ambient temperature water. And then a flow rate, let's do 6 gallons, 12 gallons, 18 gallons per minute for each of the conditions. And for each of the inputs, you can select your units to the right in the drop-down box. So for the inlet and outlet pressures, it defaults to PSI, but you can change that to bar, kilograms per centimeter squared, any of those. Temperature defaults to Fahrenheit, and the flow for liquid defaults to gallons per minute, but you can change it to any of the values listed in the drop-down box. So I'm going to keep it at PSI, Fahrenheit, and gallons per minute. I'm going to come down to the middle, and this part here says valve size. I'm going to change that to our line size that we're looking at, which in this case we can pick 1/2 inch. And then when I do that, it's going to calculate the CV for each of the min, norm, and max conditions right above it, and it'll spit that information out in the bottom portion where it says our solution. It changes to 1/2 inch. You can see it does some calculations, and it's giving me a calculated CV of 0.85 for our minimum conditions, 1.20 for our normal, and a 1.47 for our max CV, or for our max conditions. At the moment, the CV has defaulted to a 2.5, but if you come to the design CV box to the right, this is where you can put in a CV of your choice, and the calculated CV will adjust the travel percentage based on your design CV. So I look at my calculated CVs ranging from 0.85 to 1.47, and let's say I'm going to put in a design CV of 2.0. I hit calculate, and it changes my travel percentages for these three conditions. So the minimum says 42% of my 2.0 CV, normal is 60%, and the max condition is 73% travel for a 2.0 CV. So our recommended travel ranges for regulators, we try to stick between the 30 to 70% travel range. For control valves, since those have a little bit more flexibility, we try to size between 10 and 90% of travel for a given CV. Obviously, we try to strive for about 50% travel, since that gives you the maximum flexibility and best performance. Obviously, you want to be towards the middle. You don't want to be on either extreme end of your travel percentage. It's going to make the components work harder. Things are going to wear out, and you're just not going to get as good control if you're on the high or low end of those travels. If I come down to this box here at the bottom that says our solution, gives you a bunch of different information along with the calculated CV and the travel percentage. It also gives the inlet and outlet velocities as well as the predicted noise levels based on the valve size and the pipe size and schedule of the pipe. So right now it's at schedule 40 pipe. So it's telling me in all three of these conditions, I'm going to see less than 75 decibels, which is really nothing to be worried about. So that's a quick look at how you can size for a regulator, and you can adjust any of these conditions and then hit calculate again, and it will readjust your calculated CV and travel percentages. So if I do a 30 gallons per minute on my min condition, let's say that application has changed and now I'm pushing a lot more flow through there. If I hit calculate, it is now telling me that my 30 gallons per minute is going to result in 212% travel for a 2.0 CV. Obviously, you can't have more than 100% travel. So when it tells you that, it will also give you a warning of valve capacity exceeded, in which case you need to either adjust your application conditions or switch to a larger CV regulator to be able to handle that valve, or to be able to handle that application. So all of these were done with water as the fluid. And if you look at the bottom middle portion of the screen, it gives the media properties. So for water at 70 degrees, it's telling me it has this viscosity, this specific gravity, and then this vapor and critical pressure. A lot of applications will be using a proprietary fluid or an uncommon fluid, which our sizing program can take that into account. If you go to the fluid name drop-down menu and click it, the second option listed will be unlisted liquid. Now I can click that, and then those gray boxes in the middle bottom part of the screen will become ungrayed, and you can actually input your own media properties, and the sizing program will take all those properties into account. So if I had a super viscous fluid, I could change the viscosity here. You'd hit apply, and then it would your sizing would be using those properties instead of water or some other standard fluid. I'm going to change this back to water. So along with the regulator sizing, we have sizing for control valves as well. So for LowFlow, if I come up to the very top left here and change this from globe to 708, now I'm going to be sizing for the Mark 708 control valve, or one of the 708 variants that we have. So the main portion of the program looks identical, and you still input everything the same way. It's just some of the different parameters and options below it change. So I'm going to change this back to 6 gallons per minute. If I change my valve size to a 0.5, now I can select from a couple different CVs here. So I'm giving me a 0.2, 0.5, 1, 1.25, and a 2.0 CV. So if I select the 2.0 CV, it will give me that same travel percentage as it did before. But now that you're sizing for a control valve, you can increase your acceptable range from 30 and 70% to 10 to 90% of travel. And a control valve should be able to handle that. It should be able to handle those conditions. One of the things unique to control valves are the trim characteristics. So when you click on the MK708 in the drop-down box in the top left, you are given 2 options of a linear or equal percentage trim characteristic. It defaults to linear, and so that's what the travel percentages you are seeing below are based off of. If I click this on equal percentage, everything will stay the same in this program, except for the travel percentage. Since the characteristic is different and the amount of flow you get per travel is different, you can see what happens if I click equal percentage here. It will adjust these travel percentage values to be a little bit different. Because equal percentage makes the flow, the majority of the flow on the higher end of the travel. You can see that the travel percentage is jumped. And so for these same conditions, I'm now seeing that an equal percentage trim option would not be the ideal solution for all of these conditions, because the max flow conditions are now above 90%, and we try to stay within that 10 to 90% range. So you got to be aware of the trim characteristic that the customer is looking for, because although, CV-wise it might be okay based on the calculated CV that the program is showing, the actual travel percentage might be a little bit different based on the trim characteristic. The only other thing I wanted to go over, so for LowFlow, a lot of the applications are going to be dealing in very small amounts of flow, where our CV ranges could be anywhere from 0.2 to a 402 CV, something on the super small range, where the background sizing calculations are performed a little bit differently. And so in these scenarios, if you know it's going to be a very low flow application, you would go to the right module button here where it says low flow and change it from globe to low flow by clicking that button. And so what this does is this simplifies the program a little bit. Instead of choosing a CV and having a travel percentage gauged against that CV, you just input your flow conditions and your pressures, and it will give you a CV trim code that you want to use. So for example, if, let's say, the 6, 12, and 18 gallons per minute are now 0.06, 0.12, and 0.18 gallons per minute. So our flow has decreased by, a factor of 100. I can keep all these same conditions, hit calculate, and now the CV it's telling me to use here would be a 0.02 CV with a trim code of K. That is the trim code value here is an internal designation that we use. It doesn't have any effect to the customer or the end user. It just helps the factory here know which code to use and how to machine these small hand-fit CVs.